cool. Y'all can hear me. Awesome. Let me grab the clicker. So, stand in front of the line. Visualizing serverless architectures. What makes a healthy serverless application? So a little bit about me. I'm known as the node botanist everywhere other than my job because I do a lot of IoT in my spare time. I'm a developer relations engineer at IOpipe. We do AWS Lambda monitoring and observability. So we do tooling around your AWS Lambda functions so you can see what's going on inside them. And I do a lot of hardware in my spare time. And yeah. I actually wanted to start by pointing out my shirt. Our designer did a really good job with this. The text says, error, pipe is undefined. So if you know what piece of art that's a reference to, that's awesome. Because it's of French origin. Anyway. So the state of serverless operations. Obviously, there's outliers, but most of us are firmly in the category of reactionary operations. It's 4 a.m. and you get a PagerDuty alert because something's down. And you don't know what, you don't know why, you just know your app isn't working anymore. And you scramble to debug it and go forward. And you keep some metrics, but there's just way too many unknowns to know what's going on entirely with your serverless application. And that's mostly because this is such a new way of doing architecture. And it's combined with the fact that it's another level of abstraction. And so the more levels of abstraction you go up, the harder it is to visualize all the way down. So that's kind of one of the trade-offs you get when you start moving into serverless. So the ideal is instead of reactive operations to moving to preventative operations. When you start to deploy into staging, you see the memory leaks start to happen. You see CPUs CPU usage start to spike. You start to see these things before you push to production and say, okay, no, we see this becoming a problem. Or you see over each version, your memory usage is just crawling up over months and months and months instead of just overnight and having a problem. And yet being able to see your application from 10,000 meters up to just each invocation, just being able to see the entire stack, what's going on, but also being able to dig deep into those invocations to see what's going on each and every time. But how do we get from reactionary to preventative operations in serverless? The key answer is observability. And I call it the observability craze, but that kind of puts it in a negative light. It's really just a positive thing. Monitoring is out and observability is in. And observability, it allows us to handle unknowns because instead of focusing on little tiny metrics that we've already set, we're observing the entire application as it exists. And so a lot of those unknowns that we have problems with, we're able to start seeing them because we are observing the entire application instead of monitoring specific data points. It's less of a craze and more of an evolution in operations technique to be able to see what's going on inside your entire architecture instead of focusing on those data points. However, metrics are still important. It is still important to keep track of those data points. You just also want that observability. You kind of have to balance out the two. You need some landmarks to gauge where you've come from and where you're going. So over the versions of your architecture, you want to know how much you have to scale up, what's going on with your memory usage, what's going on with your code base. You want to see a timeline of your application's development. It's hard to ingest the sheer volume of data that observability gives you without some sort of categorization. And metrics definitely still help with that categorization and help with that primary, okay, what does all this data that I'm staring at actually mean to me? And metrics, when planned well, are easy to turn into easily digestible visualizations, which is important for stakeholders, which is important for you because you're staring at a graph at 4 a.m. instead of staring at logs with 500 lines of text and you're trying to frantically read this text. It can be easier to just see the visualization and see what's going on. And metrics are still really good for that. So we'll talk about some common serverless metrics, and they're going to look kind of familiar because they're very similar to non-serverless metrics, but they're slightly in different context. So you've got your memory usage and your CPU usage. This is very common, but the problem with, well, not problem really with serverless. The thing with serverless is if you're using not enough memory, then less memory than you're paying for, you're wasting money. And if you're using less CPU than you're paying for, you're losing money. And so you want to be able to know not only if you're using too much memory or too much CPU, but if you're not using enough. And you can actually scale down some of your functions into lower tiers, especially on certain providers. And knowing when to split a task off into several functions. Knowing when you've got this behemoth task that takes a ton of CPU and a ton of memory. Being able to see, okay, why does this function take this much CPU and this much memory? Oh, because we could split it off into several tasks, and also this could probably be split off to a third-party service that may not necessarily be serverless. So it's being able to see the memory and CPU usage across the whole system and across each function. Errors, of course, are a very important metric. You want to know when things aren't working. But there's more, because of the abstraction layer that I mentioned earlier, the errors can come from different levels. You could have a provider outage. You could have a third-party provider outage. Your code could be broken. You need to know what the user is seeing when you see errors, because it definitely is an interesting thing with serverless. Sometimes you'll get one error in your logs, and the user will see something completely different. So when the user reports the bug, you're like, I have no idea what's going on here on the function side of things. So error rate is something that's often overlooked, but in the serverless era is very important, because you don't need to sound the alarms necessarily if 100 errors occur over 1 million invocations, because that's a 0.01% failure rate. Error rate is just as important as the number of errors that are going on, because you need to know what percentage of your errors or what percentage of your invocations are ending in an error. Otherwise, you're kind of like thinking, okay, I've got these 4 errors, but I've only invoked the function 8 times. Okay, now I'm in trouble. Instead of it's 4 times, I'm sounding the alarm even though it's over 100,000 invocations. Cold starts are definitely a new serverless metric. And this is the idea of having to spin up a new instance or spin up a new container, or however your provider handles spinning up the environment for your function. And if you have a high rate of cold starts, that will affect your overall performance, because you have to take that extra overhead depending on the provider. And you need to be able to tell why there's a high rate of cold starts. Is it because the function's only getting called once a day? Is it because it's getting called in huge spikes, so there's no calls for like a day, and then there's like 10,000 calls in 10 minutes, and then goes back to 0 calls for another 24 hours? Both of these things could cause a lot of cold starts. And so knowing when cold starts occur, where they're occurring, and what functions are causing them is important with serverless. And there are metrics out there that will pertain to your app specifically. So the ability to define custom metrics for your application is still very important, especially in this observability era where we're trying to figure out exactly what our applications look like as a whole. So the start of that is starting to define your own custom metrics and just starting to kind of expand your viewpoint beyond just the basic metrics. The downside of custom metrics is usually this requires instrumentation of your code, but that instrumentation can be very easy, which I'll show you in a little bit. Which is now, actually. I remember that now. I took out a slide. So I'm going to do some live coding, because when has that gone wrong? I'm going to show you observing an AWS Lambda function in IOpipe. So the first thing I'm going to do, my terminal, I've already got a little bit set up here. I used the serverless framework to kind of scaffold this out. I've got package.json. I installed .env and the .env module and a .env file, so I don't accidentally show y'all my IOpipe access token, because I've totally never done that. Anyway, all right. So what I'm going to do is I'm going to npm install IOpipe's core library, and then IOpipe's tracing library, and then IOpipe's profiling library, if I remember the right words. I'm going to rely on the internet here. All right, fantastic. NPM 5 is so much faster. Yes. All right. Warnings. I don't care about those. Just hurry up and install. Come on. There we go. Okay. So I have the IOpipe installed. I'm now going to instrument my code to call IOpipe. So this is a very basic invocation. It's honestly just the serverless boilerplate modified a little bit, but we're going to add some things to it. So the first thing we're going to add is the IOpipe library. I need to learn type faster. All right, and then we're going to bring in our tracing library. And I'll show you what that means here in a moment. Trace. And then profiling, which is our newest feature. And what it allows us to do is actually we're going to be able to see a CPU profile of our Lambda function in the Chrome DevTools. Profiler. All right. So then we're going to instantiate our IOpipe. IOpipe lib. And token is going to be process.env.IOpipe token. All that practice is really paying off. And plugins. So array and trace function, and then profiler with the option of enabled set to true. Profiler is disabled by default because CPU profiling does impact performance significantly, so you would never want to use profiler in production. You would only want to use it in staging, because otherwise you're adding probably like 3 times the length of each invocation. So we disable it by default just in case. Well, how did that get back there? All right, save. Okay, so then this is the really, really tricky part, so hang in with me. I'm going to have it called just the basic. So I just wrap IOpipe around that, and that's it. That's the part I really like. That's all I had to do to get IOpipe going, is pulling it in, telling it to add the plugins, and then just wrapping my function call. Now what I'm going to do is add some tracing. So const mark equals context dot IOpipe dot mark, and then I'm going to say mark dot start silliness. The reason I'm calling it silliness is because I'm going to do for let x equals 0, x is less than and this is just so my function doesn't take like 0.03 milliseconds to run. Then x plus plus again, cuts that in half. Okay, and then mark.end. Would help if I could remember to keep my hand on the home row. .end, silliness. All right. And then for custom metrics, I'm actually going to have to look that one up because that is the one part of this demo I've forgotten. Pardon. So I'm going to do serverless deploy. And while that's deploying, I'm going to open up another tab here, and I'm going to kind of, this is going to look like cheating, but I swear it's because I knew I'd forget something. Handler. That's why. Okie doke. So while that's deploying, I'm going to add my custom metric here. Context. Are you kidding me? I was just looking at it, and then I lost it. Oh, good. Still there. Right. .log. IOpipe.log. And this is our custom metrics functionality. So I'm going to say hello. Hello, not that. Oh, my goodness. Live coding. It's the best. And then world will be the value of my custom metric, because that's original. And then I'm going to go back here, and do an entertaining little hand wiggle while it finishes checking stack update progress, because conference Wi-Fi. Okay, I actually have something to do while we're waiting for that. Of course, then it pops. Murphy's Law. So, serverless, invoke, function. Would help if I spelled things correctly. Hello, Serverlessconf. Please work. Love it when it works, especially live coding. It's totally not terrifying. Anyway, so this is the IOpipe dashboard. As you can see, we have that new purple line. The green line is from the one I wrote this morning, just to make absolutely sure I remembered everything, even though I didn't. And here we go. We have our function, hello Serverlessconf. So we're going to click into it. And then, so you can see some of the metrics I talked about, and some I didn't. Just the sheer number of invocations. I kind of left that slide out because it felt kind of obvious in a sense. We do want to know how many times our functions are being invoked. And the invocation duration is important because we want to know if our function takes 10 seconds. If a user's waiting for 10 seconds for something important, that can be tricky. We also measure by percentile. So if you've got an anomaly, you can alert on an anomaly. Like, okay, if it's in the 99 percentile, like, or the first percentile, or whatever, alert us. Memory, invocations with errors. No errors for this time period because I remembered how to live code. And then you can go into each and every invocation, and it shows when an invocation is a cold start. This was a cold start because it was a brand new function. So we've got the ability to drill down into each and every invocation. We've got the ability to view the that is not the way the link was supposed to go. Oh, right, because it's the ARN. You can take this ARN, post it in a CloudWatch, and immediately get the CloudWatch logs for your function. So if you want to balance observability with AWS's tools, you totally can. Oh, that's why I clicked the wrong link. There we go. Come on. Yeah, I'll let that load. All right, so duration, 250 milliseconds. That's because I had that really long loop in there. Cold start, yes. Memory usage, we used 42.6 megabytes out of 124. So this is what I mean by you want to know if you're using not enough memory. For instance, this is the free tier for AWS. So I'm not terribly concerned with it. But let's say I was paying for a function that had more memory access, but I was still only using 4% of that memory 99% of the time. That's just throwing away a lot of money. So you want to know how much you're using at any given point. CPU usage, same thing. You want to know, hey, is my code optimized? If 99.4% is idle, maybe, maybe not. Worth looking at. So no custom metrics recorded, huh? Oh, right, because I added that after I deployed. But tracing is there. So you remember I marked silliness. So that loop took 17.8 milliseconds of my function invocation time. So out of the 240-something milliseconds that the whole function took, silliness took 17.8 milliseconds. So I know exactly what part of the function is taking longer than the others. So we've got profiling. The profiling data for this function is going to be remarkably boring. So I'm prepared with one that's less boring. So this is the CPU profile from a function that we demonstrated at AWS reInvent in December. And what it does is we have a visually impaired programmer on the team. He shuts his screen off. And we use Slack because we're a remote team. And we send images to each other. And we felt like, okay, well, he can't see the images. So we wrote a Slack bot to take the image, run it through AWS image processing, and return a description back to Slack of what the image is. That way, everyone on the team knows what's going on in the image. It's also really good when you're on a low cell phone data plan in another country, like some people are right now. I don't have to download each and every image my coworkers post because I got a nice little description underneath it. Anyway, so this is the profiling from that, which is a lot more interesting because you can see the entire stack trace. And so this one, especially, this ended up being our credentials call. And we ended up refactoring it after this. And this one is the regex that determines whether there is an image in the Slack function. And so you've got these huge stack traces, and you can dig down into each and everything and say, OK, where is this coming from? Especially when you've got errors. Cool. Especially when you've got errors, things like that, you want to know what's going on. And the CPU profiler can very much help out with that. While that loaded, No, right? That's why. Okay. So, yeah, that's my demo. Oh, custom metrics. Actually, I'm going to demo that while I finish my slides. I will deploy it, and then I will show it. Being efficient. Also, I'll probably end early, which is great, because that means we'll be back on time. That, and it meant I talked way too fast. Okay, so the other key element to observability is time. If you can see your entire application for 1 second and that's it, that doesn't give you much. Especially when you're trying to debug an error, because the only thing you see is the application when something's wrong. So it defines a healthy serverless application is up to the application. So it's the trick question in my title, is it's up to the application. And that's why observability and time are such key components to serverless applications going from reactionary to preventative, is being able to look at your entire architecture, your entire function, and also be able to drill down into those instances, drill down into those incidents, and see what's going on, and being able to see the difference. That's the marking of a healthy serverless application, is the ability to know when it's healthy, when it's not, what's the difference. Speaking of time, the world of serverless observability and operations is trying to keep pace, but the explosive growth of serverless use in production makes it kind of hard. It's surprised a lot of folks how fast serverless has grown. If you told me when I started at IOpipe that a conference like this would have a full room like this in a little less than a year, I'd be like, yeah, okay, maybe. But now, look at y'all. Like, there's a ton of you here. I'm here. But the future is bright because the tools are getting better. Not just third-party tools, but providers are starting to get on the same train as their developers and say, okay, this is what we need to do to make our applications more observable. Thank you for listening. Before you applaud, I'm going to show you the custom metrics. Let's do that now. Feel free to approach me throughout the day, by the way. I'm wearing a mask when I'm not on stage. That's not because I'm sick. My immune system's kind of garbage. So it's actually to prevent me from getting sick. So feel free to approach me. I'm not going to get you sick. If anything, you might get me sick. So please don't. And anyway, did it deploy? It deployed. All right, we're going to invoke it. It's because I did the jazz hands. If I didn't do the jazz hands, it would break, I promise. I know this to be true. All right, so we've got our new invocation. Also a cold start because we deployed a new function. Custom metrics. Hello world. So setting those custom metrics, at least in IOpipe, easy. A lot of providers are starting to offer custom metrics. AWS offers custom metrics natively. A lot of other providers are starting to do that. Use them. They're great. The tracing and profiling are stuff we're really proud of. And I am proud of y'all for listening and being awesome. Carl Sagan thinks you're awesome too. And I am Kassandra Perch. I am node botanist on Twitter, GitHub, Blizzard, everything. And I am a developer relations engineer for IOpipe. And the fact that I managed to make it through that sentence without tripping up over developer relations engineer twice now is pretty great. Thank you very much.